2 variances or standard deviations. So we will be doing a hypothesis test for 2 population variances or standard deviations. So some notation that you may have seen before, this S1, N1, sigma 1, that's for the first sample, and then second sample. Now S1, you need to be aware of this, and N1 and Q1 is the larger. That's a big deal. So whichever one has the larger sample standard deviation is what we're going to use for the first one. So larger equals the first sample. So you can read this. They're independent, populations are independent, samples are simple random samples, blah blah blah. The hypothesis test we're going to use in this case is the variance of 1 is equal to the variance of 2. HA, I should have used H1. I may have told you before, I'm custom using HA. H1 would be the variance of the first one, might be not equals to the variance of the second one, or it could be first one's greater than, or it could be less than. Keep in mind, S1 squared is the larger of the two, so that is a big deal. We are using the F distribution. This is a little bit different. And the main difference is the fact that our test statistic is this right here. So it's a division. And so if they have equal variances, that means that the ratio of the two variances will tend to be close to 1 if they're equal, because anything divided by itself will be 1. Any number divided by itself is 1. So if they're equal, then they should be equal to 1. But we're not going to assume that they're going to be equal. I mean, they could be, but chances of that happening are not very good. So let's do some examples so you can see where that could come into effect, that 1 could. Let's keep in mind, this is an F. So the first thing you have to recognize is that sample B is larger because the sample size is larger. So this is going to be we're going to use this for sigma 1 squared, even though it's an S. So I should do this. That's our standard deviation 1, that's our sample standard deviation 2, because the larger one always comes first. Get that, it's always first. That's a big deal. So now let's go to our calculator. Let me move this over a little bit. Stat test. This time we're looking for an F test. This is an F test. 2 sample F test. Enter. Now this has stats, so sub data. So our sigma 1 is the 5.93. It's always bigger. N1 is 41. The second sample standard deviation is the smaller of the two, it should be 4.78. Then N2 is 28. Now, and that's why it's a big deal. So what I need to look at is we have an alpha is 0.05. Our HO, we're doing sample variances, or population variances I should say, so those are always sigma squares. And so we're saying that the two are equal. And then for our alternative hypothesis, I can't put equals in there, well, because different means they're not equals to. So when I go into my graphing calculator again and want to make sure it's on the not equals to, which it is, and click enter. And then if you're looking for an F stat, that would be 1.54 if I go to 2 decimal places. The p-value is 0.2418. That is not what I just said. 2.418 is what I said. And that is definitely less than 0.05, which means fail to reject HO. And so, there is no evidence to support the fact that they come from different, or the variances are different. There's no evidence to support that they claim that the samples come from populations with different variances. Now, I'm going to use StatCrunch. Also, I've already got I don't have the data values in, but in StatCrunch, you gotta be a little bit careful here. So let's go to Stat, and then let's go to Variance Stats to Sample. Let me make this bigger. So Stat, Variance Stats to Sample with Summary. So variance, see, this is variance 1. I don't have the variance. So I have to come over here to my graphing calculator, and I'm going to have to find the variance. So that's 5.93 squared, because standard deviation is 5.93. When you square that, you get the variance. 35.1649. It has a sample size of 41. So you have to be really careful what you're given and what you type in. Variance of the second one is 4.7. I meant to type it over here. 4.78 squared, which is 22.8484. Sample size is 28. And once again, this is a not equals to, so I'll keep it on the not equals. I notice it's a 1 because these are ratios which tend to be close to 1 if they're equal. Then click compute. Drag this up so you can see everything. F-stat 1.5394, 1.54, and the p-value, which is really close to what I have. There's a range that's accepted. Makes me curious to see what I did, if I did anything wrong. This time I'm going to go up that way. Make sure I typed in everything correctly. And it could easily be around an error, by the way, with my variance. 5.93, 41, 4.78, 28. Then that's how it probably is, so you will have some differences. It will accept, the system will accept both values for the p-value. So, and the reason why I say that is, well, it's could be off slightly, which is not a big deal. It's close enough. But the reason why I say that is because if you remember when I typed this in, that's just an estimate based on the standard deviations. Now let's do one with data values. So this one, we have to be really careful with what we do. This is alpha equals 0.05. I don't know which one is the first sample yet, so I know that my HO is going to be, we're doing variances, larger variance, so variance of the first one is equal to the variance of the second one. And I know I'm going to have a relationship or a comparison of those two, but it says larger. I don't know which one is the women and which one is the men. I can't say for sure yet, because I don't know which one has a larger standard deviation. So I had to find that first. So I'm going to go into my calculator. And if I go to stat, you'll notice that edit, I already have these values in. So I'm going to do first is go to stat, calc, 2 var stats, and hit enter. And then enter. I want L1 to be X list 1, Y list. If I'm doing this correctly, I may not be doing it correctly. We'll see. No, I didn't think I was. So let's go to stat, calc, 1 var stats. Let's keep it on L1. And so I'm looking at SX. So this has a standard deviation of 15.59. Let's go back into stat, calc, 1 var. This time I'm going to go to L2 and see its standard deviation is 13.75. I have to do that. No way around it. I already have these values in StatCrunch. They're already in there. So I go to stat, and then if I go to summary stats column, I can do var1, var2, and then just go to standard deviation and click compute. And I can see those values I just found. I'm always hesitant to move that because it doesn't want to act the way I need it to. Just so you can see. See how much faster it was with Stat Crunch. And so, that is a big deal, by the way, because that means that since this one is bigger, the women are S1, are the first, and the men are the second. So, women have a larger variance. That's going to be greater than now. If it were reversed, I would have to maybe change the sign or change the notation or just make sure that I know what I'm looking at. You have to make sure you know what you're looking at. Since I said the women are the first sample, because they have to be, because they have a larger standard deviation, then it's definitely greater than. If it were turned out that the men had a larger standard deviation, I would still use sigma squared 1, but then it would have been less than, because sigma squared 2 would have been the women. The women would have been larger. So that is a big deal. Now let's go in here and go to stat, test, go up to elf test. This time I'm going to do data. And keep those like they are. And this is a greater than. So let me highlight that. Enter. And so I have a F stat. What do I use it up here? How about I didn't use T? I have F. Okay, good. I was right. It's always good. So my F stat, or F statistic, is 1.28. My P value would be 0.3506, and with Stat Crunch I can do that pretty quickly. I'm just going to go to edit. Now I'm going to cancel. I'm going to delete because I want to keep that in there. Stat, variance stats to sample. It goes out the screen again. Stat, variance stats to sample with data this time. So you can see that var1 is the first one, var2 is the second one. We're doing a greater than. Click compute, and drag that up. I'm going to attempt to move it over. Yes, I know I can highlight the other thing or minimize it. I may have to, just so we can see it side by side. Hopefully you can see the 1.28 and the p-value 0.3506. See that? It's all good. It's all wonderful. Let me drag that over, just in case I wanted to make it bigger. Okay. And anyhow, since 0.3506 is greater than our alpha, 0.05, failed to reject HO. What does that mean? There's no evidence to support the claim that test scores for women have a larger variance than test scores for men. There's no evidence of it. And that's it.